A wireless local area network, WLAN, enables devices to communicate wirelessly within a specific area. WLANs use IEEE 802.11 standards, and the most common types are based on Wi-Fi technology. Wi-Fi allows devices like laptops, smartphones, tablets, and IoT devices to connect to the network without the need for physical cables. In a wireless network, several key components play essential roles in ensuring seamless connectivity and secure data transmission. At the heart of it all is the Wireless Access Point, AP, a central device that serves as a bridge, connecting wireless clients to the wired network. Acting as a wireless connection point, the AP allows clients to join the network effortlessly, facilitating communication between devices. To distinguish one wireless network from another, each WLAN is assigned a unique name called the Service Set Identifier, SSID. Clients use the SSID to identify and connect to the correct network, ensuring they access the intended network environment. Security is of paramount importance in wireless networks to protect against unauthorized access and data breaches. To achieve this, WLANs must be safeguarded with robust security settings. Encryption protocols like WPA2 or the advanced WPA3 are implemented to secure data transmitted over the wireless network, ensuring that sensitive information remains confidential and protected from potential threats. By incorporating these key components and security measures, wireless networks can provide seamless and secure connectivity for users and organizations alike. For this lesson, we'll use a Cisco router to configure a basic WLAN. Let's go through the steps in more detail. The commands Enable and Configure Terminal grant administrative access to the Cisco router's configuration. In configuring our wireless network, we begin by creating the SSID my_WLAN using the wireless SSID command. This unique name will differentiate our WLAN from others, allowing clients to identify and connect to it. To facilitate easy client association, we use the Authentication Open command, enabling clients to connect to the access point, AP, without any restrictions. Ensuring the highest level of security, we employ the Authentication Key Management WPA version 2 command, implementing the robust WPA2 Wi-Fi Protected Access to security protocol. WPA2 offers enhanced protection for our network and data, safeguarding against unauthorized access and potential threats. To secure our network with WPA2 PSK authentication, we set a passphrase using the WPA PSK ASCII0, your _passphrase_here command. It is essential to replace your _passphrase_here with a strong and memorable passphrase of your choice. This passphrase will serve as the key for authenticating clients, ensuring that only authorized users can access our wireless network. By following these steps, we create a secure and reliable wireless environment, providing seamless connectivity for our users while protecting our data from potential vulnerabilities. In this configuration process, we are preparing the router's interface, specifically Gigabit Ethernet 0/0, to function as the wireless interface. To activate the interface, we use the command No Shutdown, ensuring it is enabled and ready for use. Next, we set the native VLAN for the interface with encapsulation.1q1 native, allowing the access point, AP, to work seamlessly with tagged VLANs. Finally, we associate the interface with Bridge Group 1 using the command Bridge Group 1, as it will be utilized by the BVI, Bridge Virtual Interface. This ensures smooth communication and connectivity for our wireless network. By following these steps, we effectively configure the router's interface to serve as the wireless interface, paving the way for a well-functioning and efficient wireless network environment. In this configuration process, we are setting up the Bridge Virtual Interface, BVI, to serve as the gateway for wireless devices connecting to the WLAN. The BVI acts as the central point of communication between the wireless network and the rest of the network infrastructure. To create the BVI, we use the command interface BVI1, which creates the BVI with the number 1. Next, we assign the IP address and subnet mask to the BVI with the command IP address 192.168.1.1255.255.255.0. It is important to modify the IP address as needed to match the specific requirements of the network. To activate the BVI and allow it to function as the gateway, we use the command No Shutdown. This ensures that the BVI is up and running, ready to handle the wireless device's communication and provide connectivity to the rest of the network. By following these steps, we successfully configure the bridge virtual interface, establishing it as the gateway for the WLAN and enabling seamless communication for wireless devices within the network. Securing the WLAN is crucial to protect sensitive data from unauthorized access. Let's use WPA2 PSK as an example. Step 1. Enter configuration mode, if not already in it. In this configuration process, we focus on securing the SSID, my_WLAN, within the wireless network. To achieve this, we first enter the specific configuration mode for this SSID using the command wireless SSID, enabling us to make changes dedicated to this particular SSID. To ensure robust security for the wireless network, we implement the WPA2 Wi-Fi Protected Access 2 security mechanism with the command Authentication Key Management WPA version 2. WPA2 offers advanced encryption and authentication protocols, providing a high level of protection against unauthorized access and potential security threats. To complete the configuration, we set a strong WPA2 PSK pre-shared key passphrase for authentication using the command WPA-PSK ASCII0, your _passphrase _here. It is essential to replace your _passphrase _here with a unique and secure passphrase of your choice. This passphrase will serve as the shared secret between the wireless clients and the access point, ensuring only authorized users with the correct passphrase can access the wireless network. By following these steps, we successfully configure the SSID my_WLAN with the robust security of WPA2, safeguarding the wireless network from potential security risks and unauthorized access. When troubleshooting WLAN, wireless local area network issues, a systematic approach is crucial for identifying and resolving problems effectively. To begin, we check the power and connectivity of the access point, AP, to ensure it is operational and properly connected to the wired network. Next, we address potential interference and range issues that may impact the wireless signal. This involves examining for any sources of interference, such as microwave ovens or other wireless devices, and investigating if physical obstructions are affecting the signal's reach. We then focus on client connectivity, ensuring that devices can detect the WLAN's SSID, service set identifier, and attempt to connect. Verifying the correct passphrases entered is crucial for successful client authentication and network access. Finally, we conduct a thorough analysis of the AP's logs to identify any error messages or anomalies that might indicate underlying issues. Reviewing the logs can provide valuable insights into the health of the WLAN and help pinpoint specific areas that require attention. By following these troubleshooting steps, we can diagnose and resolve WLAN issues, ensuring a reliable and stable wireless network environment. To ensure a robust and dependable WLAN, it is essential to adhere to these best practices. 1. Utilize strong encryption protocols such as WPA2/WPA3 to safeguard data transmitted over the WLAN, protecting it from potential security breaches. 2. Implement regular changes to the SSID and passphrase, bolstering security measures and deterring unauthorized access attempts. 3. Strategically position access points, APs, to achieve optimal coverage, preventing dead zones and reducing interference for improved network performance. By following these guidelines, you can establish a secure and efficient WLAN environment. For a deeper understanding of WLAN configuration, practice these commands in a lab setting or through simulation tools, gaining practical experience. Should you have any further questions or require additional clarifications, feel free to reach out. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.